Imagine a place so extreme that our entire understanding of reality breaks down. A place where time doesn't just slow, it practically stops, and gravity pulls with such ferocity that not even light can escape. We call these places black holes, and at their heart lies something even more mysterious: the singularity. Or does it? For years, scientists have believed that inside every black hole lies a singularity, a point where mass compresses to infinite density, creating an object with zero volume and boundless gravity. It's like trying to imagine all of Earth crushed into the size of a grain of sand. But what if this bizarre concept, this singularity, isn't actually real? What if the very idea that forms the foundation of black hole theory is wrong? Today we're diving into a radical idea shaking up the world of astrophysics. What if singularities don't exist? Stay with us as we explore the theories that could redefine our understanding of black holes and the universe itself. Alright, so here's the challenge. For decades, singularities have been a critical concept in astrophysics. According to Einstein's theory of general relativity, once you cross a black hole's event horizon, that's the point of no return. All paths lead to a singularity. At this core, space and time bend to infinity, and the laws of physics simply stop working. But that's a problem. How can we claim to understand the universe when, at the heart of black holes, we're left with equations that lead to infinities? Some physicists argue that this singularity might just be a mathematical placeholder, not a physical reality. In other words, the idea of a singularity could simply mean that our math has reached its limits, not that the universe has created an actual point of infinity. So if singularities might not exist, what could lie at the center of a black hole instead? One revolutionary idea comes from a physicist named Kerr, who in 1963 proposed a new type of black hole that spins, now known as a Kerr black hole. Unlike a static black hole, which supposedly has a point like singularity, a Kerr black hole could have a ring-shaped singularity. I think of it as a cosmic loop, where space and time twist and bend around a rotating ring, rather than converging to a single, infinitely dense point. In Kerr's model, this ring is what defines the black hole's center. Instead of a dead-end singularity where physics breaks down, Kerr's ring-shaped singularity might allow particles and even information to pass through it. This is mind-blowing because it suggests that the black hole could theoretically act as a gateway, possibly connecting different regions of space and time. What's even wilder, some researchers believe this ring could allow for something called closed time-like curves. In simpler terms, it might allow paths that loop back on themselves, creating a kind of time loop. Now, before we dive down the science fiction rabbit hole, it's important to note that while these are mathematically possible in Kerr's model, they're still speculative. But they give us a glimpse of just how complex black holes might really be. Let's get to the key moment. What would it mean if Kerr's ring singularity or something else entirely replaced the traditional idea of a singularity? Well, for starters, it would mean that our current understanding of black holes is missing something huge. If singularities don't exist, then black holes don't end in a place where physics breaks down. Instead, they might open up entirely new possibilities for how space, time, and matter interact on a cosmic scale. Think of it like this: rather than black holes being cosmic death traps, they might be more like extreme intersections, where the rules of our universe twist and warp in ways we can barely imagine. And if that's the case, then black holes aren't just destructive, they might also be transformative. So, where does this leave us? If singularities aren't real, we're left with a universe that's even stranger than we thought. Instead of collapsing into nothingness, black holes might be creating new pathways or connections within the fabric of space-time. This idea challenges some of the deepest assumptions in physics and opens up questions that we're only beginning to explore. But perhaps that's what makes black holes so fascinating. They're the ultimate cosmic puzzle, a mystery that, no matter how much we learn, only seems to get more complex. If you want to keep exploring the mysteries of the universe, hit subscribe or check out our next video. The cosmos has so much more in store.